Welcome to Geotopia for you, your one-stop destination for all things geography. In this video, we are going to discuss about Aeolian geomorphology. Robert Edison Fulton Jr. once said that the desert tells a different story every time one ventures on it. Contents of the video. Number 1. Introduction to Aeolian geomorphology. Number 2. Aeolian erosional processes and associated landforms. Number 3. Aeolian transportation processes. Number 4. Aeolian depositional processes and associated landforms. Number 5. Fluvio-aeolian landforms. So without any further delay, let's begin. Introduction to Aeolian geomorphology. All landforms created by the wind are called Aeolian landforms. The term Aeolian has been derived from the Greek god of wind, Aeolus. Aeolian landforms are best developed in arid and semi-arid regions, that is, deserts. Wind is the most active agent of erosion in arid regions which are devoid of vegetation. Aeolian erosional processes and landforms. Aeolian erosional processes. Number 1. Deflation. Deflation is a process of removing, lifting and blowing away dry and loose particles of sands and dusts by wind. This process cannot affect larger and heavier entities. Number 2. Abrasion. Sand particles carried by wind attacks rock surfaces from all sides and erodes them through the mechanism of groving, pitting, polishing and fluting. Number 3. Attrition. When the erosional particles carried by the wind collide against one another, they are comminuted into finer particles. This process is called attrition. Aeolian erosional landforms. Number 1. Lag deposits or stone pavements. Some alternate names for this landform include gibber plains, desert pavements, gobi, reg, serir or hamadda. Deflation winnows away silt and fine particles and leaves behind a residue of coarse materials on the ground which are too heavy to undergo deflation. These coarser materials protect the underlying finer materials from further wind erosion. They are called lag deposits. Where the stone surface is flat and the stone cover is continuous, surfaces covered by lag deposits are called desert pavements. In this slide, you can notice the formation of lag deposits. Number 2. Deflation hollows and pans. The alternate name for this landform is called blowout. Deflation can scour out large depressions called deflation hollows. They normally occur in weak, unconsolidated rocks. Pans are closed depressions that are common in many dryland areas. They seem to have been formed at least partly by deflation process. Pans sometimes have lunate dunes on the leeward side. Presence of such a dune is a sure sign that a pan has undergone deflation. In this slide, you can notice the formation of a deflation hollow. Number 3. Mushroom rock. The alternate names for this landform is Pilfelsen, Gara and pedestal rock. Mushroom rocks have a broad upper portion and a narrow base, just like a mushroom. They are formed by wind abrasion. The base of the rock is abraded from all sides by the sand particles carried by wind. As a result, the base becomes narrow. Abrasion does not take place at upper levels as wind is unable to carry sand particles high above the ground. As a result, the upper portion is eroded and it remains as it is. In this slide, you can notice the formation of mushroom rocks. Number 4. Inselberg. The alternate name for this landform is Bornhard. The term Inselberg was first used by Passarge in 1904. Inselbergs are the sharply rising residual hills. According to L.C. King, Inselbergs are formed due to the twin processes of scarp retreat and pedimentation over coarse-grained igneous rocks. Inselbergs are also located in humid and subhumid climates. In this slide, you can see the picture of an Inselberg. Number 5. Demoiselle. Demoiselles are rock pillars having relatively resistant rocks at the top and soft rocks below. They are formed due to differential erosion of hard rocks which suffer less erosion and soft rocks which suffer more erosion. Demoiselles are maintained so long as the resistant cap rocks are situated at the top of the pillars. In this slide, you can see the picture of how a demoiselle looks like. Number 6. Yardang. The alternate name for this landform is coxcomb. Yardangs are steep-sided, deeply undercut ridges separated from one another by long grooves, passages, or corridors. They are formed when alternate hard and soft rock layers are arranged vertically. Soft rocks are eroded and blown away by unidirectional wind, forming passages. The hard rock layers remain standing as ridges. Their most significant feature is the parallelism. In this slide, you can notice the formation of Yardang. Number 7. Zeugen. Zeugen are rock masses of tabular form representing a capped ink pot standing on softer rock pedestal of shale or mudstone. They are formed when alternate hard and soft rock layers are arranged horizontally. Water in the pores and crevices of the rock freezes during night, thus expanding in volume and creating pressure on the rock. Alternate freeze and thawing causes disintegration of rocks along the joints. The eroded materials are blown away by the wind. In this slide, you can notice the formation of Zeugen. Number 8. Ventifact. Cobbles and pebbles on desert surfaces often bear facets called ventifacts. The number of edges are denoted by the German terms Einkantar, which means one-sided, Zoikantar, which means two-sided, and Dreikantar, which means three-sided. The three-sided Dreikantar is the most common among them. Ventifacts are thought to have been formed by blasting by silt rather than sand blasting. In this slide, you can notice the formation of ventifact. Aeolian transportation processes. Number 1. Surface creep. Surface creep is the process by which particles too heavy to be lifted by wind are dragged across the surface by wind blowing from a direction. In this figure, you can see how surface creep occurs. Number 2. Suspension. Particles less than 100 micrometers in size are lifted up by wind eddies and carried several kilometers away from the point of origin. These particles are deposited on the ground once the wind force completely dies out. In this figure, you can see how suspension activity takes place. Number 3. Saltation. Saltation is a process by which large grains of sands and gravel move through the process of intermittent jumping. The particles are repeatedly lifted and dropped by gusts of wind. In this figure, you can notice how saltation process takes place. Number 4. Reptation. Reptation is closely related to saltation. As the saltating grains fall on the ground, they strike other particles in their vicinity which are dislodged in different directions. In this figure, you can notice how reptation takes place. Aeolian depositional processes and landforms. Aeolian deposition. Aeolian deposition is a very significant process. Aeolian deposition leads to the development of many important landforms such as sand dunes, loess, and wind ripples. Aeolian depositional landforms. Number 1. Ripple marks. Ripple marks are regular wave-like undulations lying at right angles to the wind direction. Wind ripples form in minutes to hours and quickly change orientation if wind speed changes. Ripple marks can be of two types: longitudinal ripples and transverse ripples. In the slide, you can notice how a ripple marks looks like. Number 2. Loess. Some alternate names for these landforms are limo and adobe. Loess represents thick deposits of unstratified, non-indurated, buff-colored, well-sorted, fine-grained sediments. Loess deposits occur at places far away from the source of origin of the loess. Initial reliefs are covered under thick loess deposits. Loess is readily eroded and a dense network of rills and gullies is formed. In this slide, you can notice the picture of how a loess landform looks like. Number 3. Sand dunes. Sand dunes are accumulations or mounds of sand built piecemeal by the wind. Height of sand dunes ranges between a few meters to several hundreds of meters. The length too can vary from 5 to 6 kilometers. The windward slope is generally gentle and the leeward slope steep. Sand dunes are formed by accumulations of sand due to obstruction in wind speed caused by fixed obstacles, for example hill, rock, trees, etc. Sand dunes are mobile landforms. They migrate in the direction of wind movement. In this slide, you can see the picture of a sand dune filled landscape. Sand dune classification. Sand dunes can be divided into two broad categories. Number 1, free dune, and number 2, anchored dune. Free dunes can be of 4 types. Number 1, transverse dune. Transverse variety of free dunes can be of 4 types. Number 1, transverse. Number 2, barkhan. Number 3, domes. And number 4, reversing dunes. The second variety of free dunes is linear dune. Linear dune can be of 2 types. Number 1, seef, and number 2, sand ridge. Free dunes can also be star-shaped. Star dunes come in 2 varieties. Number 1, star, and number 2, network. The last variety of free dune is sheet. Sheet can come in 2 varieties. Number 1, bars, and number 2, streaks. Now, anchored dune can be classified into several types of dunes. Number 1, lee dune. Number 2, climbing dune. Number 3, fort dune. Number 4, hairpin dune. Number 5, echo dune. Number 6, parabolic dune. Number 7, nib khas. Number 8, clifftop dunes. Number 9, lunettes. And number 10, falling dune. So these were how we can classify sand dunes. Fluvio-aeolian landforms. Fluvio-aeolian landforms are created by the dual action of wind and water. They are formed in mountainous deserts. Intermontane basins in deserts are called bolsons. 3 landforms develop in these bolsons, which starting from the mountain front downwards are pediment, bahada, and playa. In this figure, you can notice all the 3 fluvio-aeolian landforms. Fluvio-aeolian landforms. Number 1, playa. Some alternate names for these landforms are khabari, mamlaha, and shats. The lake formed in the center of the intermontane basin is called a playa lake. A playa's areal extent can be a few acres. Playas can exist for days, weeks, or months before the water supply completely evaporates. Playa evaporation causes encrustation of alkaline materials such as borax. Such salt-covered playa beds are called salinas. In this slide, you can notice how a playa bed looks like. Number 2. Bahada. Gently sloping depositional plain between the playa and pediment is called bahada. Bahatas are formed by the coalescence of several alluvial fans. Thus, bahada is a wholly depositional feature. The slope in its upper part ranges between 8 degree to 10 degree, but in the lowermost section becomes 0 degree to 1 degree. In this slide, you can see the picture of how a bahada looks like. Number 3. Pediment. Pediments situated between mountain front and bahada are broad, extensive and gently sloping areas of rock-cut surfaces which spread around the bases of mountains as aprons. Their slopes of transportation cut on bedrock, usually covered with a thin veneer of alluvium in transit from higher to lower levels. The general gradient ranges between 1 degree and 7 degree. In this slide, you can notice the picture of how a pediment looks like. So that was all for this video. Here are the names of some books which I consulted for making this video. Thank you very much for watching. If you liked our content, please like our videos, share them and subscribe to our channel. Thank you.